Hello, and welcome to the Technical Architecture presentation SSE Plus course for the Symantec Web Gateway version 5. My name is Kevin Kingston, and I'm a Principal Field Enablement Manager for this product. This training course guides technical sales audiences to effectively address aspects of the product architecture. Upon completion of this course, you will be better prepared to answer some of the more challenging questions posed by customers during the technical presentation and product demonstration. By the end of this training, you should be able to articulate the high-level architecture overview for Symantec Web Gateway 5 so your customer has a clear picture of the product structure. Describe the different deployment options available in Symantec Web Gateway version 5. Identify the security and protection features available in Symantec Web Gateway version 5 depending on the mode it's deployed. Identify the processes and interfaces that form the basis for how the Symantec Web Gateway version 5 is managed. Recognize the different interfaces used to integrate the Symantec Web Gateway version 5 with Windows Active Directory. And know where to look for additional information and next steps. Okay, so let's get started. The first thing we'll do is look at the high-level architecture of the Symantec Web Gateway. This slide shows us the different scanning modules that comprise the architecture of the Web Gateway and shows examples of how they provide protection. In the first scenario, we see our client machine attempting to access the site www.malware.com. In this scenario, the domain or IP address the client machine is attempting to connect to is known by Symantec to be a bad site. Therefore, the Web Gateway will block attempts to connect to this site. This list of domains and IP addresses the Web Gateway blocks access to is data gathered from Symantec's Global Intelligence Network. In our second scenario, our client machine is attempting to access the site www.naughty.com. This site could represent a pornography site or another type of site that administrators don't want their end users accessing. The administrator has configured his policy to prevent access to these types of sites, and therefore in this situation the Web Gateway prevents the user from accessing the site. In our next situation, we can see the user attempting to download this file named bad PDF from a malicious web server. Now in this situation, this site wasn't identified as a bad site, but when the user tries to download the bad.pdf file, it's scanned by the Symantec antivirus engine, which identifies bad.pdf as a virus, and the download is prevented. In the next situation, our client machine is attempting to use instant messaging chat clients, or some other type of application the administrator wants to prevent from getting out to the internet. And in this situation, the application control module blocks these connections from getting out to the internet. In the next scenario, the Web Gateway can see the client machine in the network trying to send or upload some kind of data to some sort of Dropbox on the internet. In this situation, this activity has triggered an infected client signature. This lets the Web Gateway identify this infected client machine on the network and also prevents this infected client from phoning home back to this Dropbox on the internet. In the next scenario, we can see our client machine connecting to known command and control servers on the internet. These multiple patterns of bot behavior help the Web Gateway to identify the client machine as being an infected botnet in our network. It will then prevent any further bot activity from this client machine from getting out to the internet. These are the main layers of protection provided by the Web Gateway. One new module in the Web Gateway version 5, missing from the last slide, is our new file-based reputation module called Insight. If enabled, this module can be used to enforce policies that will only allow users to download portable executable files that are known by Symantec to have a good reputation. And now we'll move on to look at the available deployment options. There are generally 4 different ways to deploy the Web Gateway. On the left, we see a port span or tap deployment. In this type of deployment, the Web Gateway uses a network tap or a span port in a switch to get a copy of all the network traffic passing through the core switch of the network destined for the Internet. In terms of protection, it's the least effective way to deploy the web gateway, but it's probably the easiest method to deploy the web gateway and can be a great deployment method if looking to do an evaluation. The big disadvantage with the web gateway when deployed in port span or tap mode is that although the AV engine is able to see malware files being uploaded or downloaded through the web gateway, the engine is not able to block the malware files it sees, and it only has the ability to log this information. The second method to deploy the web gateway, as we can see on the right-hand side of the slide, is to deploy in inline mode. When deployed inline, the web gateway sits in a critical part of the network, normally between the core switch in the network and the Internet firewall or gateway. When deployed in this manner, this forces the network traffic heading inbound or outbound to pass through the web gateway on the way to its destination. When deployed inline, the web gateway provides a very good level of protection. However, you won't have the ability to decrypt HTTPS traffic. You won't have the ability to integrate with Symantec DLP when deployed inline, and failover and load balancing can be expensive. You may also run into customers who have policies where they won't deploy inline devices. In this situation, discussing the proxy deployment method with the customer is probably the best approach. The third deployment option is deploying the web gateway as a proxy. This is an entirely new deployment model to the web gateway version 5. As an explicit proxy, client machines can be directed to have the web gateway proxy their HTTP, HTTPS, FTP, and SOCKS traffic. When deploying the web gateway as a proxy, HTTPS decryption, as well as integration with Symantec DLP products is possible. Configuring failover and redundancy is also easier when deploying in this method. Some of the disadvantages when deploying as a proxy is that the web gateway will only see the traffic which is being proxied in the environment, which means some of the application control functionality cannot be used, and the infected client and botnet detection modules might not be as effective. The fourth web gateway deployment method is to deploy the web gateway in inline plus proxy mode. When deploying in this mode, the web gateway is positioned in that same critical part of the network as during a typical inline installation, but a proxy can be enabled as well, so that features like HTTPS decryption and integration with data loss prevention can also be made available. As the proxy deployment mode is new to the web gateway version 5, we'll spend a few more minutes talking about this deployment mode and some of the additional features it offers. One key thing to remember is that the traffic needs to be explicitly directed to the proxy in the web gateway version 5. The product is not a transparent proxy. As previously stated, the web gateway version 5 proxy can handle the following traffic: HTTP and HTTPS, FTP, and SOCKS. All other traffic cannot be proxied to the web gateway. Proxy redirection is normally achieved by using one of the following methods. Client machines can be directed to proxy servers in the network by using Active Directory policies. Another option is to use WPAD, or the Web Proxy Auto Discovery Protocol. A third option is to use PAC files, or proxy auto configuration files. On this slide, we'll go over a few things that the web gateway proxy can't do. The web gateway proxy is not a reverse proxy and doesn't have the ability to protect web servers from virus uploads, SQL injections, etc. Again, the web gateway proxy is not a transparent proxy, in that it can't pick up HTTP packets off the wire and proxy them. If traffic is going to be proxied, client machines need to be using some method to redirect supported protocol traffic to the proxy. Probably the biggest limitation of the web gateway proxy is that it is not WCCP capable. WCCP is a Cisco protocol that many organizations use to transparently redirect proxied traffic. This is something we are planning for a future release. The next new proxy technology we will look at will be the transparent SSL decryption that is available in the web gateway when running in proxy mode. The goal of SSL decryption is to give the web gateway the ability to inspect encrypted content, something that the web gateway couldn't do in previous product versions. This works by doing a transparent decryption, then re-encryption on the connection. Traffic is encrypted from the client machine to the web gateway. It is decrypted, analyzed, then re-encrypted to the remote web server. For privacy and performance purposes, the web gateway supports selective decryption, meaning that we have the ability to tell the web gateway to ignore decryption of certain types of traffic. For example, we may want to decrypt webmail traffic, but ignore banking and healthcare sites. The ability to selectively decrypt sites requires that the URL filtering add-on has been purchased. Otherwise, you can only selectively decrypt using domain or IP exceptions in a policy. The SSL decryption benefit to customers is the ability to scan inbound HTTPS downloads with the AV engine. For outbound, it gives the ability to scan the HTTPS uploads with the AV engine. It also allows entitled DLP customers to enable the inspection of outbound SSL traffic with DLP Network Prevent for Web. This slide describes how SSL decryption works in the web gateway. Effectively, the web gateway acts as an authorized man in the middle. The web gateway will on the fly create an emulated certificate for the remote web server. The client machine would then receive a certificate from the web gateway which would emulate almost all of the same attributes that the original certificate had. The difference in the certificate is the signing authority. The web gateway can't sign as the original signing authority. It will sign the certificate as the web gateway signing authority. The root certificate used to sign a certificate is configurable in the web gateway. Each web gateway has its own unique signing root CA it will use, or a customer can import their own signing CA that the web gateway will use instead. We recommend customers import their own certificate, mainly because if multiple web gateways exist in an environment, and you are using the unique signing root CA of each web gateway, each signing CA from each web gateway will need to be imported to the client browser as a trusted root certificate authority. If you use your own, it's easier to import that into each web gateway, and then only that one certificate needs to be imported into the client browsers as a trusted root certificate authority. Most certificate errors will translate directly through the web gateway as if the client was seeing the original remote web server certificate. There are a few exceptions here, most commonly a bad signing authority. In situations where we can't simulate a certificate that we know will be bad on the client browser, we will display an HTTP warning page. We've already briefly touched on this, but in order for SSL decryption to be transparent, the client browsers must have either the web gateway's default root CA or the customer imported signing root CA installed as a trusted root certificate authority. The web gateway maintains an internal root CA store and certificate revocation list, and we can update this as we want through web gateway database updates. Customers have no ability to modify the trusted CA store. The web gateway version 5 proxy can act as an enforcement mechanism for the data loss prevention Network Prevent for Web product. This integration also requires that the web gateway be running in proxy mode. Support for DLP Network Prevent for Web is strictly supported on DLP version 11 only. The web gateway will pass HTTP and, if we are intercepting it, HTTPS post and put requests to the DLP server. We also include the source IP address of where this content came from. DLP will then deliver a verdict. The verdict will either be good, and this will allow the traffic to continue to its destination. It will be to block all, where we won't allow any of the content to be uploaded, or the decision will be to modify the content, which will replace the content with whatever DLP gives us to replace the content with. The connection from the web gateway to the DLP server happens via an ICAP connection. To make things easier on the customer, they only need to add the DLP server IP address or addresses. The default DLP port and timeout period is pre-populated in the Web Gateway DLP settings. When you enable DLP on the Web Gateway, it will start to pass any post and put requests to the DLP server or servers for scanning. All DLP configuration and actions to be taken, or DLP reporting, all happens on the DLP servers. This slide has a diagram demonstrating how the Web Gateway integrates with the Data Loss Prevention Network Prevent for Web product. On the left we see our client machines. Their outbound post and put requests pass through the core switch and then up to the Web Gateway proxy. The Web Gateway proxy then passes these requests to the DLP Network Prevent for Web server. The requests are analyzed and, if allowed, are sent back to the Web Gateway, back down to the core switch, and out to the Internet. If the Web Gateway receives a block all verdict from the DLP server, the content is blocked and not allowed out to the Internet. If a modify content verdict is received, the content is modified and then sent on to its destination. In terms of hardware options available, there are two Web Gateway hardware models available for purchase from Symantec, the Web Gateway 8450 and the Web Gateway 8490. The top two statistics refer to the Web Gateway when deployed inline. You can see the Web Gateway 8450 supports approximately 1,000 concurrent users, while the Web Gateway 8490 supports approximately 10,000 concurrent users. In terms of throughput, the Web Gateway 8450 supports approximately 100 megabits per second, while the Web Gateway 8490 supports approximately 1 gigabit per second. You can see the Web Gateway 8450 takes up 1 U of rack space, while the Web Gateway 8490 takes up 2 U of rack space. The 8450 has one WAN LAN interface, which can be used to protect one inline link, whereas the 8490 has two WAN LAN interfaces, which can be used to protect two inline links. Each appliance has a dedicated management and monitor interface. Both appliances have redundant power. RAID on the 8450 is set to RAID 0, and on the 8490 to RAID 5. The Web Gateway version 5 offers a new virtual edition, where we now have the option to deploy the Web Gateway virtually. The Web Gateway virtual machine will need to be hosted on a server running ESX or ESXi 4.0 or above. This requires 64-bit supporting hardware. The virtual machine itself will require 2 physical or logical CPUs, although we recommend 4. It will need to be allocated 6 gigabytes of RAM, although we recommend 8, and 90 gigabytes of hard disk space. In terms of limitations, we're not recommending you deploy the Web Gateway inline in virtual environments. The big problem here being there's no way to support the hardware bypass virtually. Now we're going to talk a bit more about the protection and security features offered by the Web Gateway. The Web Gateway provides 6 layers of malware protection. The first 3 layers protect end users from accessing bad sites. The malware web domain and IP-based lists are lists of bad domains and IPs that are collected from Symantec's Global Intelligence Network. If the URL filtering add-on is purchased, it also contains some additional malware, spam, and phishing website categories. The next layer of malware protection is the malware content scanning layer. This is the Web Gateway's ability to scan files that are being uploaded and downloaded through the Web Gateway with Symantec's antivirus engine. The next 2 layers of malware protection is the Web Gateway's ability to detect compromised endpoints in the network. These modules are pretty big differentiators when compared with our competitors. The first is the method in which the Web Gateway can use network fingerprints to identify malware-infected clients on the network. The second is the method in which the Web Gateway uses behavioral-based patterns to help detect botnet-infected clients in the network. This slide goes over what can be scanned by the Symantec antivirus engine in the product. The Web Gateway scans native HTTP, native FTP, and FTP tunneling over HTTP. HTTPS uploads and downloads can be scanned in proxy deployments with SSL deep inspection enabled and if the sites are being intercepted. The Web Gateway also controls the IM upload and download channels. and if IAM transfers are allowed, they will be scanned on our supported IAM client list. With the set of IAM clients we support both the native IAM client or the web-based IAM clients that tunnel over port 80. The web gateway can't scan files being uploaded or downloaded using peer-to-peer clients. The reason here being the nature in which peer-to-peer applications work, and that the web gateway never sees a full copy of the files being transferred. If peer-to-peer downloads are a concern, you should look at blocking this type of communication using the application control functionality. This slide shows an example of the patience page and what the end user sees when downloading a file via HTTP. At the top we see the progress bar telling us the web gateway is scanning the downloaded file. On the bottom we can see when the download has completed, and if there were no threats found, the user clicks a link which then downloads the file from the web gateway to the user's client machine. This slide shows an example of the block page that an end user will see if trying to download a file infected with malware. In this case, the user has tried to download the icar.com test virus. We'll now spend a bit more time talking about the infected client detection module we mentioned earlier. When client machines get infected, they often have some kind of call home component which tries to connect back to the internet. Symantec has created signatures based on these call home components so that the web gateway can detect these infected clients on the network and stop these machines from phoning home somewhere. So just a little bit more detail on how it works. Normally a user's machine gets infected with some kind of keylogger, Trojan, or some other type of malware without their consent. Often this malware has some kind of call home component where it tries to send data back to the internet, or tries to connect to some internet Dropbox to upload sensitive data from the client machine. This phone home back to the internet usually follows a particular pattern. Symantec creates network fingerprints based on these patterns, and this is what helps the web gateway detect these infections in the network and blocks these client machines from phoning home. A lot of care is taken when writing these fingerprints to make sure we don't cause false positives. Very few vendors have this ability, and the few that claim to don't do it very well. A similar differentiating module is our botnet detection module. This is a bit more behavioral based in the way it works. If the Symantec web gateway starts to see any type of bot-related behavior from a client machine in the internal network, it will start to more closely monitor that machine. If further bot-type behaviors are seen, the web gateway will identify a client machine as an active botnet and start to block this botnet traffic from leaving the network. Botnet behavior can be quite hard to detect. The web gateway detects patterns of typical bot traffic, watching for the command and control communication. Things like connections to IRC servers, IP scans, or clients trying to send SMTP. When internal machines start showing some of these symptoms, they are determined to be suspect, and a closer eye is kept on these machines. If we see more symptoms of bot-related traffic while monitoring suspect systems, at that point the combination of symptoms will allow the web gateway to determine that the machine is a bot and will start blocking this bot-related traffic. Typically a bot will go dormant after sending their payload for a period of time. When this happens, the bot is marked as inactive. But if we start seeing bot-related behavior from that device again, we don't need to go through the suspect period again. And as soon as we start seeing this new bot behavior, that machine will be tagged as an active bot, and again we'll start blocking that bot activity. If the URL filter add-on has been purchased, the web gateway can monitor, allow, or block access to over 100 million sites organized within 62 different categories. On this slide, I've taken a screenshot to show a couple of the categories and subcategories available within them, to give an idea how this looks when it comes to policy configuration. Another thing worth pointing out is that while the URL add-on is an add-on purchase in most situations, it's actually included with the base license in the Symantec Protection Suite Enterprise Edition for gateways. This slide demonstrates that an after-hours configuration can be applied to group policies to allow different actions to be taken outside of normal working hours. On the left-hand side of the screen, you can see my working hours policy, which is more restrictive than the after-hours policy you can see on the right-hand side of the page. This slide shows an example of the URL block page an end user will see when trying to access a website where access has been restricted. In this case, a user is trying to access a sports website, and these types of sites have been restricted by the administrator. The next module we'll look at is the Application Control module. which can be used to block, monitor, or allow access to over 100 applications and protocols supported by the Web Gateway. These signatures are not port reliant, so the Web Gateway can still detect types of traffic, even when traveling over non-standard ports. Application control effectively gives administrators the ability to write policy for client access that isn't URL-based. There are over 100 different applications and protocols supported. The Web Gateway supports some instant messaging applications, some gaming applications, some database applications, and many more. The Web Gateway supports many protocols as well, ranging from file transfer protocols, email protocols, to network and remote access protocols. You can configure your policy to block, monitor, or allow access to entire categories. For example, you can block all supported types of gaming clients, or you have the ability to block an individual supported gaming application if desired. When it comes to the supported instant messaging clients, we can configure the Web Gateway so that only chat is allowed and not file transfers. If transfers are allowed, AV scanning happens on these file transfers for the supported instant messaging clients. One additional point worth calling out here is that the application control module isn't going to be as effective if running in proxy mode, mainly because the Web Gateway is normally only going to see the traffic that is being proxied in the environment. This slide shows some examples of the application control categories available when configuring the application control portion of a group policy. The last security module we are going to look at is also the newest and one of the most exciting new features released in the Web Gateway version 5. This is the addition of Symantec's new file reputation engine we touched on earlier, which is called Insight. The Insight reputation module leverages the anonymous usage patterns of over 75 million users to compute reputation scores for every executable file on the planet. We are currently tracking over 1.5 billion unique executable files, and we can assign a file reputation score without ever having seen a file. Symantec Insight technology uses context to focus on the biggest advantage cybercriminals have, and it turns it against them. Cybercriminals employ rapid mutation technology to prevent security solutions from identifying the signatures of their code. The Insight technology finds newly mutated programs and rates their level of risk based on how new and common the program is, as well as its source and other security metrics. The Web Gateway can be configured so that if a file doesn't have a good enough reputation, the Web Gateway can block this file from being downloaded. Now we're going to take a look at the reporting and administration of the Symantec Web Gateway. All administration of the Web Gateway is done through a secure web user interface. The console is separated into three main areas. There is a reporting area where reports are configured, scheduled, and viewed. There is a policy area where all group policies are created and modified. And finally, an administration area where all system configuration, system status, and system updates are controlled from. In environments where multiple web gateways are scanning web traffic, customers may opt to nominate one device as a central intelligence unit. This device can then be used to centrally manage policy configuration and reporting data from the scanning web gateways in the environment. One thing worth pointing out is that a device can't handle multiple roles, meaning that a device nominated as a central intelligence can't actually scan traffic. Likewise, a device set up as a scanning web gateway can't also act as a central intelligence for other scanning web gateways in the environment. This slide demonstrates the dashboard view seen when logging into the Web Gateway user interface. The Web Gateway actually opens up to show us the current executive summary report. At the top of this report, we get a view as to the current system status and whether the appliance is currently up to date. Below this status bar, we can view current statistical and threat information regarding web traffic in the environment from a single page. On the bottom left, you see the most popular types of websites being accessed by clients in the environment. On the right, we get insight as to whether there are currently any infected clients in the environment. Administrators have the flexibility to create different web filtering policies for different users or clients within the organization. This is all done from the Policies configuration page. Policies are ranked in precedence based on how they are ordered on the policy configuration page. Precedence is ordered from top to bottom, so if multiple policies could be applied to a user or computer in the environment, the policy closest to the top of the policy's configuration page will be the policy that will be applied. When creating a new group policy, a key step is to identify the users or machines to whom the policy applies. Administrators have the ability to create group policies based on subnet, IP range, or numerous LDAP attributes if integrated with Windows Active Directory. For example, if integrated with Active Directory, users who belong to an IT organizational unit may be given access to a broader set of URLs and applications than users, say, belonging to an accounting organizational unit may be allowed. Templates can also be created to help serve as a starting point or baseline when creating new group policies. Multiple sets of end-user pages, or the pages shown to users when trying to access content or pages that are being blocked, can be created and applied to different group policies. For example, if users speaking different languages will be protected by the web gateway, a special group policy could be created on a per-language basis for the different users, and a set of localized end-user pages could then be applied to the different group policies in their local languages. Pages are already localized into 19 different languages to help facilitate the creation of regional end-user pages. Admins can also take advantage of custom variables to customize the feedback given to end users when trying to access these pages that are being blocked. The Web Gateway includes a full set of reporting options that helps customers gain insight into the performance of their web security deployment, identify potential attacks, and track web application use. With the executive dashboard and rich set of executive summaries and other preset reports, customers can quickly identify issues and report to other stakeholders on the health of their web environment. There is a flexible reporting workflow for customizing reports, which can be exported and scheduled for automatic recurring report generation. There are 9 pre-built reports available in the Web Gateway. Reports can be highly customized, and admins can really drill down into the reporting to find the data they need. Reports can be saved and scheduled, with the option to email the reports or upload the reporting data to a remote location using the FTP protocol. Finally, the last topic we are going to cover is the methods available and the functionality offered by integrating the Web Gateway with Windows Active Directory. The Web Gateway supports integration with Windows 2003 and Windows 2008 Active Directory. Active Directory integration gives the ability to identify what users are logged into the client machines in the environment at any point in time. This info can then be used for generating reports on different users and can also be used to create and enforce policies based on LDAP groups. There are 2 methods to integrate with Active Directory. The first is to use DC interface or domain controller interface. This is an agent that must be installed to all the domain controllers in an environment. The second method is to use Windows NTLM authentication. When deployed inline, the Web Gateway uses NTLM version 1 and 401 HTTP authentication. When running in proxy mode, the Web Gateway uses NTLM version 2 Proxy 407 authentication. So a little bit more detail on how DC interface works. As I previously mentioned, DC interface requires an agent be installed to all domain controllers in an environment. This agent then monitors the security event logs on the domain controllers in real time, and immediately when a user logs into a client machine, the username and IP address is sent to the Web Gateway. The Web Gateway then queries Active Directory for the user's name, so it's then returned the user's LDAP attributes, such as group membership. When this happens, the Web Gateway can then report in its logs that activity from this IP address will be from the logged in user. The Web Gateway doesn't need to constantly keep querying the directory when users log in or out. It will cache the user's details for 1 week by default, but this is configurable. So a final summary on DC interface. When using DC interface, the Web Gateway immediately learns who is logged into what IP. The DC interface service transmits login events containing the user and the IP address they've logged into to the Web Gateway real time, and this data is encrypted. DC interface can add load to a domain controller, and the current limitation is somewhere around the 10,000 user mark. DC interface can also be run inline or in proxy mode. So now let's take a closer look at how NTLM authentication works. When a user first attempts to browse through the web gateway, either via an inline deployment or a proxy deployment, before the user is allowed to continue browsing, they are challenged by the web gateway for their AD credentials. In an inline installation, this is a 401 challenge for credentials, happening via HTTP, and in proxy mode, this is a 407 challenge, being handled by the proxy. This authentication will normally be transparent, although possibly less so with the inline NTLM challenge. The web gateway then tries to authenticate against the directory with the user's credentials. If the authentication is successful, the web gateway will then query the directory for the user's LDAP attributes, similar to the way this works with DC interface. Now that the user has been identified and associated with the IP of their client machine, the user is now allowed to browse. Per user reporting and user-based policies can now happen after a successful authentication. Some final details on NTLM authentication. NTLM version 1, which again is used inline, would be considered by some to be insecure. Transparent authentication is normally going to be difficult when not using Internet Explorer. Transparent authentication isn't going to be possible for client machines that are not part of the domain. Newer operating systems like Windows Vista and Windows 7 won't actually accept NTLM v1 challenges. When talking about NTLM version 2, this is a more secure form of authentication and more compatible with newer operating systems. The only disadvantage is that it's only available in proxy mode and not available in inline or span tap mode. Just some general Active Directory limitations. A web gateway environment can currently only support one AD forest. SSL traffic cannot be authenticated, meaning that if a user immediately starts browsing to an HTTPS site, the web gateway can only apply IP-based policies until some HTTP traffic is generated and the user can be identified. This isn't an issue if DC interface is being used. In terms of next steps, for internal Symantec, check out the Messaging and Web SymIQ site. All announcements and the latest materials are posted there. For Symantec partners, try downloading the Web Gateway Virtual Edition, which should be available on the Symantec website. There's no better way to get your hands dirty than to do some testing and playing with the product. Also speak to your Symantec technical contact. They can put you in touch with the latest materials. So just a few comments in summary. Spend time getting more familiar with the different modules and deployment options. Remember, not all features are available in all modes. Help customers recognize how the product's technical architecture relates to their goals and environment. And finally, recognize limitations and address these issues with comprehensive solutions. Thank you for completing the Symantec online course. Your feedback on the course will better help us meet your training needs. The evaluation link can be found to the left above the transcript for each presentation. This concludes this training.